Here in example number 1, we are interested in finding the values of x for which the series is convergent. This question is actually pretty similar to what you did on your test when you were given like a series, an infinite series, that is to represent e to the x. And that question asks you for what value of x would this infinite series be convergent. Well, in order to find the radius of convergence, we are going to use the ratio test. So in order to set it up with the ratio test, I need to look for the ratio between the n plus 1 term compared to the nth term. And looking at the series itself, when the term is n plus 1, I will have n plus 1 factorial times x to the power of n plus 1. This is the n plus 1 term. And find the ratio between this and the nth term. And we can now take the absolute value, try to reduce the expressions here, which give us n plus 1 times x. Once again, absolute value of this. And for ratio test, we will take the limit as n tends to infinity for what we see here, which only involve the n here. So knowing how we have n plus 1 times the absolute value of x, if I have n tends to infinity, if this approach to infinity, regardless of what value you are using for your x, you're still going to get to infinity. Well, of course, that's if you have your x equal to some number not equal to 0. But if you actually have x equals 0, anything times by 0, even though you have infinity for n plus 1 times by 0 for x equals 0, you will still end up with a 0 for your ratio test. So in order for your series to be convergent, knowing how you want your limit to be less than 1, this is the only case that will give us a ratio less than 1. Or in another word, for this series to be convergent, I want my x to be 0 only. So in this case, this infinite series will be convergent only when you have x equals 0.